Hello everyone, welcome back to my channel Alpha Beta Gamma, and we are discussing the chapter Static Electricity. The electricity which is produced due to the transfer of electrons from one material to another material due to the friction between them. And this is lesson number 4. This lesson is about electric potential and potential difference. This is our first point in this lesson. And our second point in this lesson is deriving a formula for electric potential due to a point charge. Let us move to the first point. So this is about potential, electric potential, which is related to the given electric field. Here we have the diagram which shows the electric field of considered or given charge. The given charge is placed here, and this given charge may be positive or negative. Amount of the charge is Q. Around this charge Q, the electric field is developed, and here in our diagram the charge Q is positive, and we can consider the negative charge also. Since it is the positive charge, the electric lines of force are away from the charge. Now, what is potential? Electric potential. Potential is nothing but an amount of work done. So what type of work done on which particle or a charge the work is done? This work is done on another charge which is initially inside the field. Electric field, external field, and we have to consider another charge here, and this the second charge is denoted by Q naught. This Q naught is initially outside the field. Comparing with the surface area of the electric field, the position of the Q naught which is outside is considered to be infinity, as it is not within the field. When it is placed inside the field, depending upon the nature of Q naught, if it is a similar charge or opposite charge, there is a force of attraction or repulsion is acting between the two charges. This Q naught is to be placed at any point here. Here we have that point which is at a distance r from the given charge Q. The Q naught itself will not move into the field. We have to do some external work. An amount of external work must be done to place Q naught within the field. So once Q naught is placed at any point within the field, the amount of work done is calculated, and amount of work done per unit charge, W divided by Q naught, is equal to the electric potential at that point where Q naught is placed. So this is the point where Q naught is placed, and at that point electric potential equals to the total work done on Q naught per unit positive charge. It means Q naught must be a positive charge. Q may be a positive charge or negative charge, but the Q naught which is placed from infinity to the point A, this is the point A, must be a positive charge. W by Q naught, work divided by Q naught. This is the potential at the point A, which equals to work done on unit charge, and that too Q naught is a positive charge. Why only positive charge? Why can't we take a negative charge? The Q naught may be a negative charge. Why can't be not be a negative charge? So generally, as I said, the electric properties are described or analyzed, explained with respect to or standardizing positive charge with respect to positive charge. This is the reason why all the parameters, all the quantities like electric force, electric intensity of electric field, flux density or potential and potential difference, next point, all are calculated with respect to positive charge only. This is the reason why electric potential equals to work done on unit positive charge. Then, what is potential difference? Potential is the work done to bring Q naught, the charge which is outside, to a point within the field. Electric potential refers to the work done at the point, at one point. Potential difference. Potential difference is the work done to move, to displace the positive charge which is considered Q naught from one point to another point. So this is the electric field, and here suppose this electric field is of charge Q, and the Q naught which is already at this point A, it has to be moved to the point B. To move Q naught from A to the point B, an amount of work must be done on Q naught. And again here also the work done is calculated considering Q naught is a positive charge. This amount of work done, which is applied on Q naught to move Q naught from the point A to B, within the field only, between 2 points the unit positive charge is moved. So this W by Q naught is the potential difference between A and B. We write it as VAB. And again here, this potential difference within the field, it is calculated, and both potential and potential difference are the amounts of work. But we should remember one thing, that either the potential or the potential difference, the amount of work done is against to the direction of the field. We have to move Q naught into the field for calculating electric potential, or between A and B, the amount of work done is calculated against to the direction of the field. So, electric potential is the amount of work done on unit positive charge to bring the charge or to place the charge at a point A from infinity to that point A against to the field. Here the potential difference between any 2 points A and B is the amount of work done on unit positive charge to move the charge from A to B between the 2 points against to the electric field. So both are against to the electric field. So this electric potential is the physical quantity, and This potential, electric potential, is measured in volts in SI system. Electric potential or potential difference, both are calculated in volts only, and they are represented by the symbol V. So 1 volt equals to 1 Newton meter per coulomb, this one, because work done equals to Newton meter, and work done per unit charge is work done per coulomb, which is equals to 1 volt. And here we have a small unit also, 1 millivolt, which equals to 10 to the power of minus 3 volts. 1 millivolt equals to 10 to the power of minus 3 volts. And volt is the SI unit of electric potential, and also potential difference calculated in volts only. Both are calculated in volts only. Only the difference is potential is calculated at a certain point, at the given point. Potential difference is calculated between 2 points when the unit positive charge is moved from one point to another point. So the next concept of this lesson is second point, electric potential due to a point charge. First of all, we should know what is point charge. Point charge is a charge, maybe a positive charge or negative charge, whose dimensions are negligible. The charge which does not occupy a surface area, which does not contain an area, and which does not contain volume, just it settles at one place, is known as point charge. So if you keep a point charge Q, it will not have a surface area and volume, and around this charge electric field is developed. Now our aim is to calculate electric potential due to this charge. The charge is kept here, Q, this is Q only, and we have to bring another charge which is called Q naught from outside to a point here. So this is Q naught, and when this Q naught is brought into the field from infinity to the point A, then an amount of work is done. The work done on unit positive charge, work done on the positive charge Q naught, unit positive charge, W divided by Q naught equals to electric potential. Now we want to derive the formula for this electric potential here. When this Q naught is placed inside the field, there is a force of attraction between the given charge Q and the charge placed at the point A, Q naught. So the force between the charge Q and Q naught is 1 divided by 4 pi epsilon naught Q naught, this is Q1 Q2, divided by R square. This is the force acting on, that is the force acting between the two charges. Now, so this is the Q, and Q naught is here inside the field. This is R, distance between the two charges. Now we can imagine this total length R. It is divided into small parts, each part equals to dr, and the amount of work done to move this Q Q naught through a small distance dr, small amount of the work done, equals to F dot dr. F is the force, dr is the distance between Q and Q naught here. So both are here vectors. So dw equals to F dr cos theta, where theta is the angle between the force and the displacement. But the force and displacement are in the same direction here. So this is the reason why here we have dw equals to F dr cos theta, and we have here, as the work is done against the field, theta equals to 180 degrees, you will have minus F dr. So this is the work done on the positive charge to move through a small distance dr. Now we substitute the value of F. dw equals to minus 1 by 4 pi epsilon naught q naught by r square multiplied by dr. Then the total amount of the work done when the charge is moved through the distance r, total amount equals to integral dw from the limits are for position r 0 to r. So w equals to integral 0 to r minus 1 by 4 pi epsilon naught q naught by r square into dr. Then w equals to minus q naught by 4 pi epsilon naught is taken outside, within the integration 1 by r square dr, and the limits are 0 to r. Here this will be minus q naught by 4 pi epsilon naught 1 by r square integration here. So this integration 1 by r square, here we have integral 0 to r to the power of minus 2 dr. So the next step will be w equals to minus q naught by 4 pi epsilon naught. So r to the power of minus 2 is integrated, you will get r to the power of minus 2 plus 1 by minus 2 plus 1, and the limits are 0 to r. So this will be, here you will have w equals to, here we have a minus 1, minus multiplied by minus will be positive, q naught by 4 pi epsilon naught r to the power of minus 1, and the limits are 0 to r. So substituting the limits, we have here w equals to q naught by 4 pi epsilon naught 1 by r, 0 to r are the limits. So w equals to q naught by 4 pi epsilon naught into r when you substitute this. So then electric potential V equals to W by Q naught, work done on unit positive charge, V equals to potential at the point A due to the point charge Q naught by 4 pi epsilon naught into R divided by 1 by Q naught. Then Q naught will be cancelled. Here we have V potential difference equals to, we have Q divided by 4 pi epsilon naught into R. So this is the electric potential due to point charge, and the units are volts is a unit. So the potential due to point charge in the given external field is V equals to Q divided by 4 pi epsilon naught R. So in the next class we will discuss potential due to moment. Thank you for watching this video.